All right, problem number 4. We have an airplane that's going to take off. It needs to get up to a speed of 80 meters per second, and it starts from rest. We have its acceleration. And we want to calculate a couple things. First, the distance it needs to be able to get up to the speed, and then the time it takes to do that. So in these problems, I'll give you the equations, and always assume that the starting position is 0, and the final position is an unknown. We do start from rest, so that implies that v0 is 0. V is going to be 80 meters per second. We're given an acceleration of 2 meters per second squared, but we don't know the time. And this is actually enough information for us to solve the problem. So first we want to know the distance it needs to be able to reach the speed. Now since I don't have a time, I'm going to go ahead and use the third equation. So v squared is v0 squared plus 2 times a times x minus x0. So I can go ahead and plug in my numbers, and I'll get that 80 squared equals 0 squared plus 2 times 2 times x minus 0. Simplifying further, we're going to get that 6400 equals 4x, and when we isolate x, that'll actually give us our final position, or the distance that we cover. So that's going to give us 1600 meters as our distance covered in order to take off. Next, we want to get the time it takes to reach the speed. So let's pick an easy equation. V equals AT plus V0. So we know that 80 is the final speed that it gets to before it leaves the runway or takes off, equals 2 times t plus 0. And so we're going to get that 80 equals 2 times t. We'll divide both sides by 2. Those will cancel. And we'll end up getting that t is 40 seconds. All right. There we go. So that's question 4, part A. Now, let me just move this up a little bit so we can see it. There we go. So I'll put that right there. All right. Now, question 4B, a car is moving with an initial velocity of 20 meters per second. Before hitting a wall, it needs to stop, so its speed in the end should be 0. We always assume that x0 is 0, and it's hitting a wall that's 50 meters away. We don't know the braking acceleration, and we don't know the time. So let's calculate what we do have. Let's get the braking acceleration. So since I don't have time, I'll use the formula that does not have time in it. So v squared equals v0 squared plus 2 times a times x minus x0. All right. Now we'll end up getting 0 squared, because that's the speed that we end at, equals 20 squared plus 2 times a times 50 minus 0. When I simplify this out, that's going to give me 0 equals 400 plus 100 times a. We'll subtract 400 from each side. And so we're going to end up getting negative 400 equals 100 times a. And that's going to give us that a is negative 4 meters per second squared. Okay. Now, continuing, let's get the time. So v equals AT plus V0. So that's going to be V0 equals negative 4 times the time plus 20. That's the initial velocity. Now, we'll subtract 20 from both sides. So we're going to end up getting that negative 20 equals negative 4t. When we simplify, we're going to end up getting that t is 5 seconds. All right, so that's it for question number 4.